Welcome to my channel SC Hub, learn with me. Please like my video and subscribe to my channel if you are new here. Hello, our course is Database Systems. Today, we're going to learn about file systems and databases. Today's outline is following: what a database is, what it does, and why database design is important. How modern databases evolved from files and file systems. About flaws in file system data management. What a DBMS is, what it does, and how it fits into the database system. About types of database systems and database models. File system and databases. Here we discuss the data and information. What is data? What is information? Data constitute building blocks of information. It means that data is raw information. When we process the data, it forms information. For example, a list of dates, data, is meaningless without the information that makes the dates relevant, dates of the holiday. What is the benefit of information? Information is a key decision. We can work good and timely. And good decision making is the key to organizational survival. Database management. Database is shared, integrated computer structure that stores a collection of data, end user data, raw data. Metadata, data about data. It contains data characteristics and relationships. Database management system, DBMS, software system, collective software, help to manage the data contents. Number 1, manages database structure. Number 2, controls access to data. Number 3, contains query language. Application software interacts with DBMS. DBMS collects data from the database, processes the data, and gives information to the application software. Importance of DBMS, makes data management more efficient and effective. Query language allows quick answers to ad hoc queries. Provides better access to more and better managed data. Promotes an integrated view of the organization's operations. Reduces the probability of inconsistent data. Improved data sharing. Improved data security. This figure shows us, the DBMS manages the interaction between the end user and the database. End users interact with DBMS through application. DBMS communicates with the database structure and gives results or data to end user. Why database design is important. Database design focuses on design of database structure used for end-user data. Designer must identify database's expected use. Well-designed database facilitates data management. Generates accurate and valuable information. Poorly designed database causes difficult to trace errors. Historical roots of databases. File and file systems. Why we need to study files and file system. To know about historically handling data, and help to understand database design. Files and file system. First, applications focused on clerical tasks. Requests for information quickly followed. File systems developed to address needs, data organized according to expected use. Data processing, DP, specialists. Computerized manual file systems. File terminology. Data, which includes raw facts. Field, which includes group of characters with specific meaning. Record, which includes logically connected fields that describe a person, place, or thing. File and file folder, which includes collection of related records. Phenolic disinfectants are not advisable due to toxic in nature and may harm to respiratory system. How data saves in file. File system critique. File system data management. Requires extensive programming in third-generation language, 3GL, COBOL, BASIC, and Fortran. What must be done and how it is to be done. Time-consuming. Depends on physically stored data. Makes ad hoc queries impossible. Make difficult to modify file system. Each file has its own system. Leads to islands of information. The difference between data dependence and structural dependence is the main part of database. Data dependence. Change in files data characteristics requires modification of data access programs. Must tell program what to do and how to do. Makes file systems cumbersome from programming and data management views. Structural dependence. Change in file structure requires modification of related programs. Field definition and naming convention. Flexible record definition anticipates reporting requirements. Selection of proper field names important. Attention to length of field names. Use of unique record identifiers. Data redundancy. Results of uncontrolled data redundancy. Data anomalies, such as modification, insertion, deletion. Data inconsistency, such as lack of data integrity. Database systems. Database consists of logically related data stored in a single repository. Provides advantages over file system management approach. Eliminates data inconsistency, lack of data integrity, data anomalies, data dependency, and structural dependency problems. Stores data structures, relationships, and access paths. In this figure, you can see the difference between the file system and database system. In the file system, every department has its own file records. And it is difficult if one record is changed, you will change manually in all the files in different departments. But in the database system, every department communicates only with the database management system. Now, it's time for DBMS to manage records in the database. DBMS manipulates data in the database and fetches the record for end users. In this figure, you can see the difference between the file system and database system. In the file system, every department has its file records. And it is difficult if one record is changed, you have to update records manually in all the files in different departments. But in the database system, every department communicates with the database management system only. Now, it's time for DBMS to manage records in the database. DBMS manipulates data in the database and fetches the record for end users. Database system environment. Hardware. System's physical devices are computers, peripherals, and network. Software includes, number 1, operating system, that manages hardware components. Number 2, DBMS, manages database includes, MS Access, SQL Server, Oracle, DB2. Number 3, application and utility software, support access and manipulate data, which includes the following: generate information for decision-making, help to manage database system. People in database system environment, there are 5 people. Number 1, System Administrator, for hardware system support. Number 2, Database Administrator, for manage DBMS use. Number 3, Database Designer, for design database structure. Number 4, System Analyst and Programmers, for implement application programs. Number 5, End Users. Database system environment, has procedures and data also. Procedures are instruction and rule that govern the design and use of the database system. Database system types. Number 1, single user versus multi-user database, desktop database, single user. Workgroup database supports a small number. Enterprise database supports a large number. Number 2, centralized versus distributed, location. Number 3, use, production or transactional. Decision support or data warehouse, obtain information. DBMS functions. Objectives of DBMS functions are: guarantee the integrity and consistency of data. It has several functions, like data dictionary management. The definition of the data elements and their relationships are stored in a data dictionary. It removes data and structure dependencies. Data storage management, structures required for data storage. Data transformation and presentation, relieving us from the distinct between logical data format and physical data format. Security management. Multi-user access control, concurrency, backup and recovery management. Data integrity management. Database access language and application programming interfaces. Queried language, DDL and DML. Database communication interfaces. Database models are two: one is conceptual model and other one is implementation model. Conceptual models includes entity relationship database model, object-oriented mode, and implementation models includes hierarchical database model, network database model, relational database model, object-oriented database model. Relationships in conceptual models: one-to-one, one-to-many, and many-to-many. Implementation database models: hierarchical, network, relational, and object-oriented. You can see the evaluation of database models in this figure. Hierarchical database model. Logically represented by an upside-down tree. Each parent can have many children, segment linkage. Each child has only one parent. A single table acts as the root of the database from which other tables branch out. Relationships in such a system are children and parents. Parents and children are tied together by links called pointers. This is the example of hierarchical database model. Logically represented by an upside-down tree. One-to-many relationship. This is the hierarchical path starting from left. List hierarchical path, or preorder traversal, or hierarchical sequence. See the flow. Relist the sequence, if the segment is frequently accessed. And the bank system commonly use HD model. Bank systems commonly use the HDBM. Customer account can be subject to many transactions, 1:M relationship. Relationship is fixed, debiting and crediting. Frequently access large amount of transactions. Advantages of hierarchical database model, conceptual simplicity, relationship between layers is logically simple, design process is simple. Database security, enforced uniformly through the system. Data integrity. Data independence. Efficiency in one-many relationships and when uses require large numbers of transactions. Dominant in 1970s, when we used mainframe system with large databases. Disadvantages of hierarchical database model, complex implementation, physical data storage characteristics, database design is complicated. Difficult to manage and lack of standards. Lacks structural independence. Applications programming and use complexity, pointer-based. Implementation limitations, i.e. especially it only handle one-to-many type of model. Network database model. Each record can have multiple parents, called by database task group, DBTG, to define standards, and, three crucial database components are, network schema, conceptual organization of the entire database. Subschema, portion of database as information for application programs. Database management language, defining data characteristics and data structure. Schema data definition language, DDL, define schema components. Subschema data definition language. Data manipulating language, manipulate data content. Each record can have multiple parents. Introduce set to describe relationship. Each set has owner record and member record, parallel to parent and child in HDM. Member may have several owners. One ownership. Hierarchical model is a subset of the network model. The network model uses set theory to provide a tree-like hierarchy. In network database model, member may have several owners like shown below. Advantages of network database model, conceptual simplicity, just like HDM. Handles more relationship types. Data access flexibility. Promotes database integrity. Data independence. Conformance to standards. Disadvantages of network database model. System complexity, developed by the computer programmers for the computer programmers rather than user. And lack of structural independence. Relational database model, lets user or database designer to operate human logical environment. Perceived by user as a collection of tables for data storage, while let DBMS handles the physical details. Tables are a series of row/column intersections. Tables related by sharing common entity characteristics. It allows one-to-one, one-to-many, many-to-many relationships. In relational database model, database tables connect with each other. Let's take the example here. Agent_code is common between two tables. It connects both agent and customer table. This shows the relational schema, one-to-many relationship between the agent and the customer. An agent code belongs to many users. And the field agent code is the foreign key. We will study this in our next lesson. Advantages of relational database model, structural independence, data access path is irrelevant to database design, change structure will not affect the database. Improved conceptual simplicity. Easier database design, implementation, management, and use ad hoc query capability with SQL, 4GL is added. Powerful database management system. Disadvantages of relational database model. Substantial hardware and system software overhead. Poor design and implementation is made easy. May promote islands of information problems. If you like my video, please like and subscribe to my channel. Comment your interesting topics and questions in the comments section. I will discuss your topics in the upcoming video. Press the bell icon for new video notifications.